All right, so we have this problem, and this is kind of a complicated problem because we're looking for AC first of all. We're looking for that one there, AC. So in order to find AC, what we need to do is look for AC, and it's right here. AC from A to C. So we can write that down, and I'm going to say, well, AC equals 3x plus 3. So in order to find AC, though, I kind of need to know what x is, because if I don't know what x is, there's no way I can find out what AC is. So we're going to have to figure out what x is and then come back to it. So I'm just going to draw a line here, and we're going to come back to that. So in order to find out what x is, we're going to have to add two things together to set it equal to the whole and build a mathematical model. But not everything lines up. Look, I've got from A to C, but I don't have from C to D. And if I go from the other side, I've got B to D, but I don't know what A to B is. So we've got to figure out either what AB is or what CD is. And it doesn't really matter which one we do. So I think what I'm going to do is find AB. And the way I'm going to do that is I'm going to just zoom in on this right here, on this section here. We're just going to zoom in on that as if that was its own problem. I'm going to redraw it here. So A, C, with B in the middle, and we know that this is x plus 3, and we know that the whole thing is 3x plus 3. So for me, what I can do is we can put a model together. I could say, well, AB, that's this one here, plus BC equals AC. And AB we don't know, but we do know BC. BC is x plus 3. We know AC is 3x plus 3. So what I'm going to do now, let's get AB by itself. We want to figure out what AB is. We won't be able to know exactly what it is, but we'll get as far as we can go. So first thing I'm going to do is subtract 3 on both sides. 3 minus 3 cancels out, leaves us with AB plus x equals 3x, and 3 minus 3 is 0, so that cancels out as well, leaves us with 3x. So then I'm going to subtract x from both sides, and x minus x cancels out, and 3x minus 1x gives us 2x. So that's as far as I can go. So we can say that AB is 2x. That kind of makes sense. 2x plus x plus 3 equals 3x plus 3. So that scans. So I'm just going to go back to my original problem here, and we're going to plug in what we just figured out, which is this here, AB is equal to 2x. We still don't know what x is, but at least we know what AB is. So now we can put together a whole new model. So we could say BD plus AB equals AD, right? And we can do that knowing what AB is. So let's put that together. We're going to say AB plus BD. AB is this one, BD is this one. It's going to equal the whole thing, AD. So AB we said was 2x. Said that's 2x. And BD we've always known, that's 14. And AD we've always known, that's 5x plus 2. So now what we're going to do is we're going to solve for x. So I'm going to go out all the variables to one side. We're going to get all the integers to the other side. So I'm going to subtract 2x from both sides. And we get 14 equals 3x plus 2. Then we're going to subtract 2 from both sides. And we get 3x equals 12. Divide both sides by 3, and x equals 4. So we're still not done. We still need to go to the original problem, which was to find AC. So now that we know x, I'm just going to take this, and I'm going to plug this in for x right here. AC equals 3 times 4 plus 3. So 3 times 4 is 12 plus 3. So we get AC equals 15, which is our final answer.